Professor, Department of Civil Engineering, Seri Institute of Technology. I am going to present sensor application in structural health monitoring. Structural health monitoring is a process of assessing, monitoring, analyzing the condition and performance of civil infrastructure using advanced sensing technology and data analysis techniques. It also helps to detect damages, predicting failure, and also ensure the safety of the structure. Component of structural health monitoring. Structural health monitoring consists of several components that all work together to assess, monitor, and analyze the condition of civil infrastructure. The key components are sensor. Many number of sensors are installed in the structure to monitor the condition of the structures. A strain gauge. Strain gauge is a sensor which is used to measure the strain and deformation of the structures. Accelerometer sensors. This sensor is used to measure the natural vibrations and the dynamic responses of the structures. Displacement sensor is used to measure the movement of the structures. Fiber optic sensor is also used to measure the strain and also the temperature effect on the structures. Temperature and humidity sensor is used to predict the environmental impact on the structures. Acoustic emission sensor is very much useful to measure the cracks. Ultrasonic sensor is used to measure the interior defect of the material. Next, second component is data acquisition systems. Data acquisition systems is very much helpful to collect data from the sensors and data from the sensors and helps to convert that non-readable data into the readable digital form. This component is very much used for conversion of the informations to readable data. For these components, some of the key elements are required, that is signal condition units, analog to digital converters, wireless or wire transmission systems, cloud-based or non-site data storage. Data transmission systems. Transmission system is very much used to transmit the data from the sensor to the central monitoring unit. It can be transferred by using three ways wired communications. That means by using cable, the informations are transferred from sensor to the central monitoring units. Otherwise, wireless communications by using Wi-Fi or Bluetooth, informations will be transferred from sensor to central monitoring unit. Otherwise, by using some of the smart sensor cloud monitoring systems can also used for data transmission systems. Other components are data processing and analysis. The collected data are processed and analyzed. Based on that analyzing data only, engineers can able to identify the condition of the structures. For this, signal processing algorithm is very much important, which is used to monitor, predict the condition of the structure. Machine learning and AI tool is very much used for pattern recognitions. Finite element modeling is also very much used to stimulation of the structure. Big data analytics is required to handle the big data sets. Final components is decision making and interpretation systems. So based on the data analysis result, engineers will take decisions and interpret the systems. It includes generating reports on structural health, predicting failures or weakness, planning preventive maintenance strategy. Application of structural health monitoring in civil engineering. Structural health monitoring is applied in civil engineering for various purposes. Structural health monitoring is applied in bridge constructions, high-rise buildings, dams, railways and metro systems, nuclear power plants. In bridges, sensors are installed on the bridges to measure the impact of traffic and also other wind load. It also used to measure the condition of the bridges. For examples, in Golden Gate bridges, the structural health monitoring is used for continuous monitoring purpose. In high-rise building, also sensors are installed in high-rise building to measure the wind and other earthquake load. It also helps to monitor the foundation settlement also. Burj Khalifa is equipped with structural health monitoring to monitor the wind-induced movements. In dams also sensors are installed to measure the water pressure, and also it indicates the seepage and cracks in the dams. Three Gorge dams in China is also equipped with structural health monitoring systems. And railway tracks also structural health monitorings are used. Sensors are installed in railway tracks to track the alignment of the railway tracks. In nuclear power plants also more sensors are installed to monitor the impact of radiations, and also it helps to identify the condition of the cooling towers and radiators. Fukushima nuclear power plant is implemented by structural health monitoring after the 2011 earthquake. Challenges in structural health monitoring in civil engineering. First challenges is high implementation cost. In structural health monitoring, the sensors are very most expensive sensors are used. Softwares used in structural health monitoring is also very expensive. That is one of the first challenges. Second one, complex data management and interpretations. The data storage is very high in structural health monitoring. Sensor reliability and maintenance. So after few years, there is chances of degradation of sensors by some environmental impacts. Integrations with existing infrastructure. Retrofitting of old structures, old bridges with the sensor is very difficult. Sometimes it will be very costlier. Environmental and external factors. Sometimes the accuracy of the sensor is affected by some extreme environmental conditions. Limited skilled workforce and expertise. Skilled laborers will be required for structural health monitoring. The laborers should have high knowledge in civil engineering as well as some AI image processing and sensor applications. So these are the challenges faced in structural health monitoring. So we can use some strategies to avoid these challenges. So future solutions and opportunities are we can develop some low cost sensor or wireless technologies to avoid these expensive problems. And some AI and machine learnings can develop to improve the damage detection accuracy. Smart infrastructure integrations, structural health monitoring systems embedded in smart cities and digital twins. Some awareness can be given for all engineers about these structural health monitoring technologies. So these are the some of the future solutions and opportunities to avoid these challenges. Thank you.